Okay, so this will be recorded. Thanks to everyone who came here, and thank you to our speaker who will be talking about something that I think is also relevant in our everyday lives. And for people who might not be familiar, by the way, the Binalot Talks is a very informal talk that's hosted by the Archaeological Studies program every Wednesday. So we've been having this online for the past 2 years since the pandemic, but we'll slowly, hopefully move to doing more hybrid version. And I think that's also part of what the main concept of what's going to be talked about today, the concept of accessibility in archaeology and information. All right, so I will just introduce our speaker for today. Mikhail Garcia Echevarri is an anthropology and archaeology PhD candidate at the University of Washington, Seattle. As a member of the Ifugao Archaeological Project and the Bicol Archaeological Project, Mikhail is primarily focused on archaeologies of Iberian colonialism. His current dissertation research explores how socioeconomic networks changed in response to Spanish colonialism in the Bicol region. He's an advocate of democratizing research and making that research relevant to the communities in which it takes place. I'm sure you've also seen him around in ASP and also before in UP in the National Museum alongside Dr. Stephen Acabado and the other field schoolers. So he started out as a field schooler and now he is helping out with everyone there. So let's all welcome Mikhail Echevarri.
Hi, thank you for that wonderful introduction. I'm going to set up my slides. So as Anna said, I'm going to be talking about how programming, specifically Python programming, can be used in archaeology and how that advances open access goals, but more importantly, accessibility goals in archaeology. I mean for this talk to be super introductory, sort of for those of you who don't know very much about programming or coding, to sort of get a handle on what it's about and how you might look into getting started with it or utilizing it or introducing someone else to utilize it. So that's that. So here's just the general outline. I'll talk a little bit about myself, although Anna covered a lot of that. I'll introduce Python, then talk about how we use that, how that can be used for accessibility, and then go on from there. So as she mentioned, I started off working in the Philippines in 2012 with the Ifugao Archaeological Project. And worked with that project through 2016, although the project is still ongoing. And then I helped at the inception of the Bicol Archaeological Project from 2016 through this field season. We just wrapped up a month ago, our latest field season / field school. So that was pretty successful, I think. And I've been at the University of Washington now since 2015 as a graduate student. I'm focused on archaeologies of colonialism. I'm interested in socioeconomic network changes and then using ceramics as a proxy to understand those. And I'm also interested in archaeology in archaeology in video games. And if Anna has talked about inviting me to talk about that in the future, so we'll see. So Python. Basically, it's just a universal programming language. It's called object-oriented. So in that way, the mental model with Python is that you work with objects, and those objects you can think of like a car. This is an object, and the car has multiple functions. So it can open a door, you can roll down a window, you can start the car, you turn the wheel. All of those functions are housed within the larger object of the car. And so that's the same thing in Python. You can think of it, if you're thinking about it in data ways, your spreadsheet is an object and it has a bunch of different things you can do to it or do with it. So that's how that's sort of like the larger mental model of how Python works. And it's a super popular programming language. So it also has a ton of people working on it, providing add-ons or packages. So the package system is super mature. There's a lot of things you can do. If you can think of it, someone is probably working on it, or you can eventually work on something yourself to solve your specific problem. So what do I mean by universal programming language? It's multi-purpose. You can run it on any platform, a Mac, a Windows, a Linux, and for the most part, most of the code you're using, especially for what we're using it for in archaeology, you can write the code on your Mac laptop, send it to somebody, and they can run it on their Windows laptop without any problems whatsoever, without having to change anything. And also, it has high compatibility. You can use it for a variety of different things. A lot of people use Python in software development for developing apps. I think YouTube uses it for their backend, and then we use it for data science or hardware integration, things like that. And then personally, I think it's super easy to learn. It's probably one of the easier programming languages to learn. There's a lot of languages out there where if you put a period in the wrong place, everything screws up. With Python, there are rules obviously, but it's not as difficult to pick up the rules and the syntax. And I think it's pretty straightforward. It's because the language itself interprets what you wrote into a more machine-like language down the line. So you don't have to think about how your machine is understanding it. You just have to think about how you understand the code. And then on the screen here, you can see a bit of an example of what that looks like. Most of the red text is actually just comments. This is my own function that I wrote that helps me to translate written down UTM coordinates into latitude, longitude without having to open a GIS to try to do that. And so the majority of this text here is just comments that remind me how it works. And the rest is really, I think, pretty simple stuff. So, and then, like I said, there's a mature package ecosystem, which means you can add on to your basic Python installation as you need, whenever you need it. You don't have to go and download separate packages on your own. You can just type into Python, install this package so that we can use it. So in that way, it's all kind of built in. I kind of like to sell it to people as you can do a bunch of things with Python, and it all can be done in that same window. So you can get packages, and tons of people are working on them. There's a lot of built-in ones, and then you can make your own and publish them for other people to use. So some of these images on the screen are the logos of some really popular ones, especially for data analysis. And just to kind of run you through what the kinds of things you can get done programming here. For instance, Pandas is kind of like a more robust version of like Excel. So it can read in Excel sheets, even it can read in CSVs, and then you can manipulate them however you want to kind of explore the data or move it into a different format that is easier for any kind of analysis down the line. NumPy is a super robust mathematics suite that has formulas and different types of math for anything you can think of. Matplotlib can help you take all of the numbers you've just crunched with Pandas and NumPy and turn them into charts or graphs, or any kind of visualization, even 3D or moving, ones. So I use that a lot. It's really, you can very quickly, especially once you get used to it, you can very quickly take data turn it into a chart and send that chart off, or incorporate it into a publication. You have things like SciPy and scikit-learn that have more robust statistical functions, or scikit-learn even can start to work with AI. GeoPandas is kind of like a GIS. So those of you familiar with ArcGIS, you can do pretty much anything you can do in ArcGIS and GeoPandas just for free. And then finally Jupyter, and I'll talk a little bit more about Jupyter, but Jupyter is a notebook package. So I'll talk about notebooks actually in a bit. And then again, Python is super popular. This is from the PYPL programming language statistics. They look at the number of times any language is searched on the internet. So you do, when you're programming, you do a lot of searches for things you're trying to remember how to do, or specific types of code you're trying to write. And Python has grown by far to be the, over a quarter of those searches. So super popular. So again, universal programming language, very popular. It's easy to learn, in my opinion, and it's super customizable for what you need to do. So so basically, where does that fit into archaeology? Many of us know archaeology is a destructive discipline. I like to think about Gavin Lucas's definition of the transmutation of the buried material into an archive. You're taking those things that were in the ground, you're recording them, you're collecting them, cataloging them, applying decisions at every stage and turning them into some kind of archival product, and then down the line into publications. So information loss doesn't just stop at the digging part. At every stage you're making decisions, you're consolidating your categories, you're changing information, things like that. And then even in the analysis step, you're making a ton of decisions. And the problem is that when you're using a lot of GUI-based software, graphical user interfaces, like Excel or ArcGIS, you can do a lot of clicking and a lot of that types of stuff. And you end up with an output, but it's very hard to trace your steps back or to tell someone exactly what you did to get to that point. So you're left with your raw data and your output, and it's kind of like well, if you want to figure out how I did it, we're gonna sit there and walk through a bunch of clicking steps for a long time. So that's where the programming language comes in. Is it helps you to share your decision making at the analysis step, and even before that, and help walk people through exactly how you got to where you're going, or what you got to. So very quickly, you can think of most very simply, you're getting your raw data, and you're doing your analysis, and then you publish. And your analysis can be a variety of different things, but you often sort of gloss over that, or you talk about it very superficially. You maybe get the key points about p-values or a specific function you're interested in, or anything like that. But really, that analysis, you're cleaning up data. You're maybe, if you're trying to understand, distribution of pottery at a site, or to see if there's multiple different groups of people producing pottery, then you could be doing collapsing your categories, splitting categories by level. You're comparing the diversity of these categories using a specific type of diversity measure, for instance, and then you're making charts, etc. And all of that gets collapsed into this black box. What a lot of us are trying to do by trying to push things like Python or R is to make that box transparent for everybody. So you can publish everything you've done inside that box with the publishable material at the end. Another useful thing for Python to use for Python is to share how you just the processes of getting things done. So for instance, this is just a snapshot of raw elemental data from ceramic composition from a LAI CPMS lab. There's 13,000 rows here. And then we're given a Word document with instructions on how to transform that raw data into something that you can actually use for an actual compositional analysis. And then you end up with something like this. And that document, 9 pages long, with screenshots on how to click here and there in Excel, et cetera, can very quickly become outdated if Excel is updated or there's a new version or something, things like that. Whereas, as I'll show in a second, you could go from this to this by just sharing your process through Python code and having the person just make decisions along the way as it's running. So that's where the Jupyter Notebook comes in. This is sort of I think like the cornerstone of data science in things like social science is the notebook model. R does it also, for those of you familiar with R. It's the idea that you can run snippets of code and have a narrative in between those, and then show the results of every one of those code bits. So you're not just running one block. You can run, one thing, talk about the results from that, and then how that feeds into the next section, and people can see the results, what exactly you wrote to produce those results, and then your thinking behind those when you're writing about it. And you get all the same benefits from Python, the reproducibility. They work. Jupyter works with almost every package out there, so it's easy to share and review. And all you have to do is share your one document and then the data that you're inputting into it. So you don't have to do really anything else. So here's an example of a Jupyter notebook. This is the notebook I used to produce that Python popularity chart. So you can see here, I just talk about very quickly how I'm doing this. I'm importing these packages, pandas and matplotlib, the ones I talked about, to manipulate the data and then produce a chart. I'm using pandas to read in an Excel sheet that had this data in here. And then I'm telling you how I manipulated the data and then showing you exactly how I produced that chart. So this is super simple. They can get pretty complex and very long, but you get the idea here. So there you go. And then you can also export these to like a PDF for someone who doesn't have Python or Jupyter installed on the computer and they just want to see what you did. You can save it as a PDF. Okay. So this contributes to accessibility and open access goals, which I think are sort of overlapping. For open access, we're interested in sharing data whenever it's ethical. We're interested in sharing the process of analysis, like I talked about. And then we're trying to push for the free access of our outputs, like the articles and books. And so that's kind of a thorny issue at the moment. And then I think all of this goes towards just pushing for the ability to share the knowledge production power. And this is something we also push for in the big archaeological project, for instance, is we're trying to incorporate local students into the process so that they can then produce knowledge, archaeological knowledge, anthropological knowledge about people by Bicolanos. It's the same thing here. It's we're trying to give the ability for people to look at other people's work and produce their own work with that, or by copying it or modeling it or using it as a model. And you can't iterate on the methodologies if you can't see what people are doing. And so that also feeds into accessibility. And so again, Python is free, open access. And I think one of the biggest hurdles to accessibility for a lot of people is the cost of software. So I just listed a bunch of softwares that I've used in the past to do the things that we do. ArcGIS, $100 a year, Photoshop, Acrobat, $20 a month. Microsoft Office is now a subscription, $70 a year. SPSS is a statistics software suite. If you're not a student, $1,200 a year. And you can do, and so the point of open source and is to push accessibility. So now you can get QGIS, which is super robust now, for free. There's a Photoshop equivalent, GIMP. Foxit is pretty good for PDFs. Many of us are using Google Office now instead of Microsoft Office, no surprise there. And then for your statistical needs, you can start to switch to Python if you want. So that's just one way of doing it. Making things more free without the need to pirate. I think it's super useful. And then also, I think a big issue that is not talked about too much is software stability and hardware requirements. So if you're working in a software that gets unsupported, or the file types change, or it even gets updated so that the thing you were doing in it doesn't work anymore, all those things can break your flow, your workflow, and even make it so that it becomes nearly impossible to access the files you're using. And so there's file types from the 90s or the early 2000s that it's very difficult without a working computer from that era to be able to access. And even now we are using .docx for our Word documents. Before we were using .doc, and I'm wondering how long it'll take before we can't open the .doc files anymore. So that's an issue. Python has the ability to, you can very easily save the current state of your Python session. So the version of your Python, the version of all the packages you're using, save that into a document that you can send along with your Jupyter notebook. And then someone can revert their Python back to that version to be able to run your notebook exactly as you ran it. That's less of an issue at the moment with the kinds of things we're working with, but some people need to be very specific with their packages or their Python version. And then again, hardware limitations. I know that my computers in the past have struggled with large Excel files. With Pandas, you can not only just very quickly, it's more efficient with larger data sets, but also it's very good at chunking. So you can take a chunk of a data set, work with that, and then take the next chunk, work with that without any slowdown. So it's just making it easier to do things with less. And then finally, I think most importantly is access to the process. So I like to compare this to like field school. Field school is really just about introducing people who want to be archaeologists to the process of archaeology and allowing them to see how you do it, to copy you, and then to iterate on what you're doing, to do it by hand themselves, compare what you're doing to themselves, and then ultimately demystify the process. At least that's how I think about field school. And it's the same thing in a way with Python, Jupyter notebooks, etc. is you're letting people see your process, the decisions you're making, and then they can take that, copy it, and change those decisions. Maybe they didn't like that you used this specific parameter for this function, or they want to change your p-value to see what that looks like. They can do that. And see if it holds up, or if it breaks down with that, and then maybe wonder about that, and iterate. So I think that's ultimately the thing that's most important to me, is being able to in the future look at works and publications and then look at their process and work it out for myself. I'm the kind of person that needs to work on something to understand it. I can't just read through someone telling me how they did it. So in that way, it's useful. And all you really need to do is start to learn Python. Okay, getting to the end here. And then finally, just beyond the data science part, beyond just using notebooks and sharing the data and all that, once you get to know Python, you can start to do interesting things, other kinds of interesting things. For instance, I'm currently trying to hack this digital scale using an Arduino and a sort of thing that takes the scale input and pushes it to that. And I'm trying to get it so that it'll read in the scale information and input it directly into a pandas data frame. So I don't have to copy artifact weights by hand. It can just be inputted directly into your database, reducing error, making it faster, and circumventing buying like a super expensive digital scale. You can just hack this coffee scale that I bought. You can do that with Python. You can automate routines. I have a colleague who's working on image processing, so being able to identify, for instance, inclusions in thin sections of pottery, or even infer the shape of a vessel. We can get to do those things down the line if we start to work on it. Is really all that it takes, I think. And I haven't really explored this, but I mean, there's a lot of AI stuff going around now. We're seeing AI art. Why not AI archaeology? So finally, for those of you who were kind of sold on this concept or are interested in looking into it, this is how I learned Python. I took one course of R, of working with R, and at the University of Washington. Then I switched over to Python on my own. I used YouTube tutorials. I used some of these websites. Carpentries has some good Python fundamentals in there. DataCamp is kind of expensive, but there's a free trial. You can get through some of their intro courses really easily. And if you're feeling really adventurous, you can download Jupyter Notebook's standalone app, and it comes with Python installed. You can mess around with the notebooks and just get started very quickly by installing that. So I think that's it. Thank you.
Thanks for that. I think that I really like that concept that you actually changed your coffee weight, what do you call it? Weighing scale. So yeah, to automatically go into your, to get information. Okay, so if there are any questions, feel free to press the reactions button for all our guests. Otherwise, you press the reactions button at the bottom of your screen and then press raise hand so we can call on you. Otherwise, you can also directly message either me or Ara-1 if you want to ask questions, and we can read it out loud for you. While we're waiting, I also wanted to ask about this. How have you been, how do you use it for measuring or for analyzing your ceramics?
Yeah, so what I do is I wrote my own small package using on top of pandas and NumPy and all of that. And so what it does is it allows me to import that elemental data that you saw a screenshot of, and very quickly do things like run a principal component analysis, generate groupings. So I have a function in there that allows you to select out by hand groups from the principal component if you want to, and then test those. And then also it has the ability to take the groupings that you've assigned either through a principal component analysis or a hierarchical clustering model, and then test those using it's a multivariate distance measure, Mahalanobis. So, and what it does is it basically just, it'll take all of your ceramics and their elemental data and their supposed groups, and then actually test those and give you a 0 to 1 value of how well they fit with that group. And then it outputs that as a data frame.
And you're the one who wrote that, right? Or
Yes.
yeah. Have you published this?
I'm going to. I'm in the process. That's why I didn't want to totally share it today. Yeah.
Yeah, that's fine. And I think that's also cool that you managed to write that. And I think it's very helpful for a lot of people who are also sharing, interested in doing that, because I guess it's also not just for ceramics, it can also be used for other material artifacts as well. There's a question here asking if are you going to put your codes in a public repo or?
Yes. So as soon as I publish for the first time, they'll go into a public repo. They're currently on a private GitHub at the moment. So I am planning to publish those, all the things I said, publish my Jupyter notebooks, publish the code, and then hopefully people can take what I wrote and make it better, because I'm sure it can be made better. So
so I think a lot of people are also looking forward to this, and also maybe in other are there other people or other non-ceramicists who are also doing the same thing using Python?
Yeah, I'm sure there are. Yeah.
All right. So if there are animal bones people here or are interested in doing animal bones, remember that this is also a lot of elements that are also involved. So and even human bones.
Yeah. Python is artifact agnostic, so you can manipulate it however you want to.
How long did it take you to understand or to learn Python? Maybe that's also something that a lot of people can do.
Yeah, let me see here. Trying to remember. I think 2000. So basically, at the beginning of the pandemic, when we all went into lockdown, I was very worried about my dissertation project going through. We canceled our fieldwork plans that year, and then the year after. So I wasn't able to go to the Philippines and conduct the excavation and collect the data I needed to do my dissertation. So I decided to instead focus on my methodology and sort of diversify my skill set. So in like March through July, I was teaching myself Python. I had some experience with R, one quarter. So maybe half a year to teach myself, and then another half a year to a year to kind of get good enough to write my own code package.
There's a question here. What can you advise people who are planning to learn Python, and what should be avoided in the learning process?
That's a good question. I think you should, if you're wanting to learn Python, you should have a goal in mind. My goal was to learn how to do the types of analysis I needed to do, but on my own terms, and to work with the data sets that I wanted to work with. And so that helped motivate my learning. So I think if you want to work with Python, you can definitely learn it just to learn it. But I think if you have like a goal in mind, then that's probably better. Even if it's something small, like you're tired of working with Excel or something, and you want to be able to very quickly manipulate data without having to click through Excel, then that's a goal, and super achievable in a short amount of time, I think. And then pitfalls. I would just say, don't be afraid to just Google things. A lot of people have this image of like someone who's just typing away constantly, knows exactly what they're typing. But I would say like a quarter to half of the time that I'm working on code specifically, I'm like, oh shoot, how do I do this thing with this? And then I just quickly Google it. Someone has code already out there on the internet that you can just copy and paste, and there's no shame in that. So
that's exactly what I was also thinking. I was reading up on people who are coding. 90% of people who code actually get the codes that they find from somewhere else, or so it's a collaborative effort.
mhm.
There's a question from Dr. Paz. You can now open your camera.
Thank you, Mikhail. It's always refreshing to see the enthusiasm of younger members of our community to innovate, and I suppose that is really the nature of our discipline. We're quintessential innovators in trying to get a grip of this myriad data, complicated questions that we always want to ask. I like, of course, for people who are much older, you must forgive us sometimes for being too a bit jaded, because we've heard a lot of heraldings, in the past, no? And a lot of tears have been shed by institutions when they invested a lot in terms of archiving their data sets. Having said that, I'm not saying that this should not be encouraged. And by the way you explain Python, as long as it remains to be an open access program, then it looks like it's truly promising. Aside from the fact that you've demonstrated that it has all the potentials for good archiving of data, and its transparency, and its capability to do analytical work. So these are usually in the past, they're all separate, and you were explaining that all of these different open data access programs allow all of this to be done. So I see in the audience a lot of graduate students, and surely they should take note of this. And if you could learn it via YouTube, my goodness, then that's very good. But then, of course, you also, and I think you know the dilemma, and this is an age-old dilemma that really no one has a very clear answer, but we always like to ask it, the dilemma of ownership of information, of data. And you see yourself exactly in that dilemma. While you're making you do want to share, you want to have all the open access, you want people to look at the very bowels of your data, but not yet, because we have you have to finish your dissertation, right? So this membrane that separates private or proprietorship is an age-old problem we have, and it's and like I said, we can only really have a better handle if we keep on talking about it. So the wonderful attempt, of course, of the project at Bicol in the Cordillera is this attempt of being inclusive, of creating the capabilities of local communities to not only use data and information, but to generate knowledge. We should always see if we can do that. And I think this is promising. This is promising. But again, my mind was thinking, and I was listening to very intently. But then you answered the question of that stability of the program. of as long as you can migrate all the old stuff, no? But tell you what, right? If you just go further back, that's how when photography was invented or it was integrated into archaeology, or that went along. But okay, we managed to migrate that to digital form. But at the end of the day, a lot of the digital versions, data sets that we created in the past are so hard to access now. But like what you said, unless you have the the machines that were from that period. So from an institution standpoint, of course, you will understand institutions would be conservative, but I think no graduate students should be conservative in exploring this kind of avenue to crunch information or data towards knowledge. Yeah. So thank you, Mikhail, for sharing this. I hope I could learn it. Maybe in the next time I get COVID, I'll look into it.
Yeah. Yeah, thank you. Those are insightful comments. Oh, sorry, Anna.
No, I was also going to say that because there's a boot camp regarding Python, as you mentioned before, so the data camp. So they're available, but I think a lot can also be intimidating for a lot of students trying to learn this, especially as a person who's not young, is the concept of trying to apply it in what you already know. So when when a lot of people think that it's when you're just starting out, a lot of the generic boot camps that you find, they're talking about things that might not be interesting to a lot of people, or the methods, the examples that they're using might not be applicable. So in their minds, so it's I think that's one of the hurdles that they have to tackle. But in actually, I was also trying to learn Python as well. I stopped doing it, but I keep coming back to it. So it's an interesting programming language to use. But it's I think that was one of the hurdles that I had to also overcome during that the early thing. But there was a sudden click somewhere that made me realize that it's not it's really the method. It's not the examples that were being shown.
Yeah.
So I think that there's another question here. So how can you show again the slide with the data where they can get the learn Python, where they can learn Python?
Oh, yeah, sure. There it is. Yeah, and I can send you the PowerPoint if people are wanting the links.
All right.
But
so
yeah, carpentry is just like a website that has a lot of different resources. So you want to look for the Python fundamentals. I used DataCamp, the free trial, and then the University of Washington actually had a short subscription service that I was able to use also. But yeah, I got a lot of it through YouTube.
Got it. Thank you so much. And also for people in UP, I think there are some coding practices that are being offered in the ITDC. So you can just check out their website as well. Sometimes they will offer some webinars that will help you learn. All right. And hopefully by the next time, Mikhail, you can, once this is published, you can give another talk about the the research that you also did. So this is a good way for other people to start their own research. I know a lot of people here are interested in the techniques that you are giving. Oh, there's another question. What is the difference between R and Python?
I'm not sure exactly how to answer that. The Python was built from the ground up as a universal language. So it sort of does everything, but you need to modify it to do the things you want it to do. R, I think, is much more directed at doing statistical things or doing things with academia. It's why it's really popular with a lot of academics. And they're both super useful, and you can pick one or the other, honestly. They both have a notebook model, which I think is super important. And they both have the ability to expand their functionality through packaging systems. The reason I like Python better is I personally feel it's easier to pick up and write. And like I talked about, because it's more universal, it was built from the ground up for that. You can integrate with hardware, like I'm trying to do. A lot more people are using it for AI integrations or just other sorts of software development things. So I guess in theory, if you wanted to, you could use Python to build a software suite if you really wanted to, that someone could use if they didn't want to learn to code. I know that there's a couple packages in Python actually that integrate with like Excel. So for people who are working with someone who doesn't want to learn to code but wants the transparency, it'll take the things you're doing in Excel and turn them into code. So I haven't messed around with that, but it seems super interesting. Sort of like a hybrid way of doing it. But yeah, I think Python is more versatile. So if you're looking for that, then you should go to that route. But if you're really interested in something that's more geared for academics, you can definitely use R.
All right. I think that's also one of the questions here, why you chose Python instead of expanding on learning R. But I guess it's not super mutual. You can learn both. Although I've been reading some forums that were saying that you only choose one, but I think it's also helpful if you know both.
Yeah,
right.
I think if you're going to choose one and you're interested in maybe not staying in the academic sphere, I would go with Python. It's more popular. And I think a lot more like companies who have data scientists on their teams, they use Python. So.
All right. That's a good way for other people to start understanding and good motivation for people to start learning Python. All right. Thanks for this. I know that it's already late there.
Yeah,
but
it's
also
midnight.
yeah. But also thank you for sharing this. I think a lot of people have this concept really that R is mostly the more versatile and the more accessible language that they can learn, primarily because it's the university is also UP here is pushing it. But if anyone might be interested in learning Python, so you can learn it on your own pace. I know that in Manila, in the Philippines, there's a lot of people who are also teaching it online. So you can also, if you want somebody to help you with it, that's also fine. But if you want to, there's different ways to learn the coding and how it can help us in analyzing data for the future archaeological studies. But for now, well, thank you, Mikhail, for sharing this work. We hope to see your work published soon. May I ask, where are you thinking of publishing it?
I'm thinking maybe it's going to be a 3-paper dissertation, so there might be one in like the Journal of Archaeological Science, and I'm hoping to publish something more Southeast Asian centric or even just Philippine centric. So I'm still shopping around, but yeah.
All right. I have some ideas. I was actually talking to Celine Carfon, who was doing open archaeology, and I think there's a session in IPPA on open archaeology in which some of our members here are giving talks about it, especially in producing databases. So it's she also mentioned that she's interested in your work, so about publishing it.
Yeah.
She said that she will try to contact you. All
Yeah,
right.
please do. Yeah, I would go to IPPA this year, but I have a different commitment.
Yes. Is it okay to say?
Sure.
Oh, okay.
Yeah. I have my first child is on the way within any time in the next few days. So yeah, we're gearing up.
Yeah. Well, that's also why we booked Glennis early instead of
Yeah.
Mikhail. So,
Yeah.
all right.
Thank you. Yeah, because she's about to pop.
hope that's all fine there, and you're all excited. We're all excited for you for personal and also academic reasons. So,
Thank you.
thank you for that. And for now, I think that's all. For next week, we don't have a speaker yet. There was a reschedule, but the week after, we will have Susanna, who will give another talk about her research in Ili Cave, Duil Valley, Palawan. So see you all in hopefully next week. But if you have any more questions or you want to know when the next Binalot Talk will be, please do like the Binalot Talk Facebook page or the UPASP Facebook page where we will post it. All right. For now, thank you so much. Thank you, Mikhail. Good night and good afternoon, everyone. See you.